Good morning students, welcome to our video lecture. Today students, we will revise the formulas of standard deviation. Let us start the formulas of standard deviation denoted by sigma oblique s. The list of formula is as such, students, divided into two broad categories, all of you know. The first category is ungrouped data, and students, the second category is group data. The second category is group data. Again, group data is divided as discrete frequency distribution and continuous frequency distribution. This, I suppose, all of you have learned and by heart by this time. Now students, ungrouped data formulas we have already studied, but we will revise it. Ungrouped data formula. The first formula, when mean x bar is an integer, sigma is equal to positive square root of summation xi minus x bar whole square upon n. Usually this formula is preferred when mean x bar, students, is an integer. Then the second formula is preferred when x bar is not an integer, and that formula is summation sigma xi square upon n minus x bar square, or even this is written as sigma xi upon n the whole square. Now the shortcut method formula SCN is developed by writing y in place of xi and writing, you can say, instead of x bar writing y bar, and y is nothing but xi minus a. So shortcut method formula is developed by writing y in place of xi and by writing y bar, students, in place of x bar. You know y is equal to xi minus a is assumed mean. But I told you, as far as ungrouped data is concerned, we go for DM, and that is direct method. Now students, condition criteria remains same. When x bar is an integer, here our capital N will be summation of fi, and here small n denotes total observations. Students, small n, all of you, is concentrate. Small n denotes total number of observations, and capital N denotes total frequency. So the formula for both the series is same, direct method formulas. First formula, sigma is equal to positive square root of summation fi into xi minus x bar whole square upon n. Condition criteria remains same. This formula is preferred when x bar is an integer. For discrete series, xi is observation, and for continuous series, xi is the constant bit value. This much, students, distinction you should very carefully observe. I repeat, for discrete series, students, xi is the observation, and students, for continuous series or continuous frequency distribution xi is the mid value of the concerned class. The second formula is sigma is equal to square root of summation fi. Now here students, we slightly change the formula, that derivation I am not undergoing. N into summation fi xi square minus summation fi xi the whole square into 1 by n. We take outside. The formula is written in this form as given in textbook students. So please remember, it is derived from this formula only. Here we multiply fi xi square by capital N minus sigma fi xi upon capital N the whole square, take n square as LCM. But students, I am not undergoing the derivation. Please remember. And students, if I write in the shortcut method y is equal to xi minus a upon h, then students, the SCM formula will be same, but only changes h will be multiplied into under root of n into summation fi yi square minus summation fi y of the whole square. If we have divided by h, then we have to multiply by h. Otherwise, students, we write as this. So this list of formula, as far as ungrouped data is concerned, we prefer direct method. As far as group data is concerned, and especially for a continuous frequency distribution, students, we always prefer shortcut method formula SCM. So students, in short, 3 and to 5 formulas you have to memorize, and these formulas are only memorized if you write it repeatedly again and again. Still, you thoroughly memorize this formula, students. So one has to be very careful, students, in, you can say, memorizing and representing this formulas. This is a chapter which is very easy, students, very easy once you know the formula, and students, you know how to use the calculator. I don't think this particular chapter is difficult at any instant. So students, this is your prescribed list of formula which you have to write again and again when you practice. Now let us demonstrate this formulas with the help of sums. We start exercise 15.2 from sum number 4 onwards. We have done the first 3 sums, students. Now we start with sum number 4 onwards. Now students, for discrete series, I am using direct method formula so that you memorize the direct method formulas very perfectly. So students, for discrete series, I am using direct method formula so that you can memorize and understand, students, this formulas very perfectly. So we start exercise 15.2, sum number 4, students. All of you please concentrate and try to understand the basics, how we are doing the sum. Exercise 15.2. Now students, the question is this, that we have to find mean and variance. I told you don't have to work up any formula for variance. If I square the formula of standard deviation, students, we get the formula for variance. So no need to mug up any formula for variance. Now students, the given discrete frequency distribution is as below. I note down xi and fi. The observations are 6, 10, 14, 18, 24, 28 and 30. We don't need the total of only xi. Now, corresponding frequencies are 2, 4, 7, 12, 8, 4 and 3. Okay students, I told you I am going by direct method approach just to demonstrate. Now students, first of all, to operate mean, first of all let us total this will be 6 and 7, 13 and 12, 25. 25 and 12, 37 and 3, 40. So total of Fi is capital N, which is 40. To operate mean, I need the column of Fi, Xi. 6 into 2, 12, 10 into 4, 40, 14, 7 is 98. Then students, 18 into 12, 216, 216, 8 4s are 32, so 192, 8 4s are 32, 8 and 3, 11, and this is 90, 90. So if I go for the total of FISI, that total comes out to be 760. Okay, so first of all, I am operating mean, and students, mean x bar is equal to summation Fi xi upon n, and this comes out to be 760 divided by 40. So mean x bar is 90, which is an integer. So the formula of standard deviation which I am using is square root of summation Fi into xi minus x bar whole square upon n. To find variance, I just square root the sides. Sigma square is summation Fi into xi minus x bar whole square upon n. So my next column is to be operated as xi minus x bar whole square, and last column Fi into xi minus x bar whole square. Okay students, now pay attention. From every observation xi, I have to exclude x bar, which is 19. 6 minus 19 is minus 30, and square of minus 30 is 169. 10 minus 19 is minus 9, and square of minus 9 is 81. 14 minus 19 is minus 5, and square of minus 5 is 25. 18 minus 19 is minus 1, and square of minus 1 is 1. 24 minus 19 is 5, and square of 5 is 25. 28 minus 19 is 9, and square of 9 is 81. Then 30 minus 19 is 11, and 11 square is 121. This total we don't require. We have to have the product of Fi is equal to xi minus x bar whole square. Now 169 into 2 will give us 338. 338. 81 into 4. 4 ones are 4, 8 fours are 32, so 354. 25 sevens are 175. 12 is a 12. 25 8s are 200. This is again 324. And this is 3, 6, 3. So if I total Fi into xi minus x bar square, it is 1736. And variance is simplified as 1736 divided by 40. So the answer is 43.4. Final answer is students 43.4. So these are simple calculations which are only based on your calculating ability. the use of a simple calculator. Research is repeatedly and telling these are based on a simple use of calculator. Now we are doing the fifth sum and erasing this. This also I am erasing, mean also I am erasing, different. This columns the layout and keeping as it is by chance mean turns out to be integer. Then students we would be going with the same formula and the same columns, the same steps for the entire sum. Okay students, now we are doing sum number 5. Now students, all of you please pay attention. I am doing sum number 5. Again, the series is discrete. Again, students, the series is discrete. So let us note xi and f5. Xi goes in the form 92, 93, 97, 98, 102, 104, 109. So this will give us the total. Corresponding frequencies are 3232, 633. Okay students, let us total F5. Students, let us total F5. 3 2 3 5 plus 5 10, 10 plus 6 16 plus 6 22. This total is not required. 92 into 3, 3 2s are 6, 9 3s are 27, 3 2s are 6, 9 2s are 80, 7 3s are 21, 27 into 29, 8 2s are 16, 196. Then this will be 612, 312, and this will be 327. So, students, if I calculate the total, 276, 186, 291, 196, 612, 312, 327, 2200. This total comes out to be 2200. So, mean will be 2200 divided by 22, and that is 100, which is an integer. So if mean is an integer, we prefer the formula sigma is equal to square root of summation 5 into xi minus x bar whole square divided by capital N. So from every xi I have to exclude mean 100. 92 minus 100 is minus 8, and its square is 64. 93 minus 100 is minus 7, and its square is 49. 97 minus 100 is minus 3, and its square is 9. 98 minus 100 is minus 2, and its square is 4. 102 minus 100 is plus 2, and its square is 4. 104 minus 100 is 4, and its square is 16. 9 square is 81. We do not total this. Now 64 into 3, 6, 4 3s are 12, so this will be 192. 49 into 2, so this is 98. 9 3s are 27, 4 2s are 8, 6 4s are 24, 16 3s are 48, and this is 243. So if I total the last column, I am getting 640, and my variance comes out to be 640 upon 22, 25 divided by, the answer is 29.09. Students, you should know how to use a simple calculator, and want us to use the simple calculator and do the sum, I don't think students you should face any problem. So this was the demonstration of direct method formula. Now from 7th sum onwards we will be doing only shortcut method formulas. We will apply only shortcut method formula. In short, it is same for discrete and continuous series, so you need not worry. If you divide by it, we have to multiply by h. Otherwise, the formulas remains the same. I don't have handy the paper as I have shown. In this year, 1 or 2 papers, they have asked variance sums. Students in this year's paper they asked variance sums. Question 6. Using shortcut method, find mean and standard deviation. Question 7. 6 we have done. So xi and fi. Xi goes from 60, 61, 62, 63, 64, 65, 66, 67 and 68. We do total except frequencies are 2, 1, 12, 29, 23, 12, 10, 4 and 5. The last frequency is 5. Okay students, now all of you pay attention. The total of frequency is 100. So write capital N is equal to 100. Students, we go at this. We are going to do the sum by shortcut method. And in shortcut method, we take assumed mean for discrete series from given xi, and I am taking assumed mean as 64. So I am writing yi is equal to xi minus a. 60 minus 64 minus 4. 61 minus 64 minus 3. 62 minus 64 minus 2 minus 1, 0, 1, 2, 3 and 4. This total is not required, students. Now we operate and let us write the formulas first. Mean x bar is equal to a plus sigma f5 yi divided by n. X bar is equal to a plus sigma f5 yi divided by n. So I have to do the column of f5 yi. 2 into minus 4 is minus 8, minus 3, minus 24, minus 29, 0, 12, 20, 12, 20. So this positive values and this negative values, if I total, students are getting 0. So when fi total is 0, then this is 64 plus 0 divided by 100. So assumed mean and mean turns out to be the same. Students, remember this as the result. When the total of fi, students, remember this as a result. When the total of fi is 0, assumed mean and mean, students, turns out to be same. Now I am noting down the formula of standard deviation. Sigma is equal to 1 by n into square root of n into sigma fi yi square minus sigma fi yi the whole square. Now here the most important point, students, which you have to understand is this, that suppose I have a into b square, then this is written as a into b. Same way, fi yi square is obtained as a product of fi yi into y. So our final most column in the sum is fi yi square. Which is that column, students? fi yi square. And that column, students, is obtained as fi yi into yi minus 4 into minus 8 is plus 22, minus 3 into minus 3 is plus 9, 24 into 2 is 48, 29 into 1 is 59, 0 into 0 is 0, 12 is a 12, 22 is a 40, 12 is a 36, 24 is a 80. So this total comes out to be 286. Now finally, students, operating standard deviation. Our final step is to find standard deviation. So sigma is equal to 1 by n, which is 1 by 100 under root of 100 into 286 minus 0 square. Students, always remember, within the square of standard deviation, for shortcut method formula, this negative sign never changes. Even if the total of fi was negative, square of negative number is, students, always positive. Remember, this is a master stroke in the shortcut method formula of standard deviation, which is 1 by n into square root of n into sigma fi yi square minus sigma fi yi the whole square. This negative sign never vanishes. Even if this total was say minus 10, square of minus 10 is 100, outside sign never changes. So this is written as 1 by 100 into square root of 100 into 286, because 0 square is 0. Now students, square root of 100 is 10, so this becomes 10 by 100 into square root of 286. So this becomes 1 by 10. Now 17 square is 289, so square root of 289 is 17, so this will be little less than 17. So 16.9 divided by 10, so the answer is 1.69. So standard deviation comes out to be, students, 1.69. So check, this was a discrete series. This was a discrete frequency distribution. A distribution without classes is a discrete frequency distribution. If there is no mention of method, I suggest we should always go by shortcut method. method only. I repeat, if there is no suggestion or indication or direction for method, whether it is a discrete series or a continuous series, students, we should always go by shortcut method. Suppose if I would have divided by a common value, then here I will multiply by that common value, which is h. Otherwise, the formula remains same for discrete and continuous series. So students, this was the demonstration of standard deviation for a discrete frequency distribution using shortcut method. And remember, the last column fi square is always obtained as product of fi into yi, and you will never have negative value in the column fi square. And another interesting thing, within the formula of standard deviation by shortcut method, negative sign never vanishes. Always you will have negative sign between the terms. So students, we are left with question 7, 8, 9, 10. Remaining 4 questions we will complete in the next lecture to complete exercise 15.2. Thank you students.